Namaste and a very warm welcome to you. Today, we're going to pull back the curtain on something we do all the time, how computers, sometimes thousands of kilometers apart, manage to talk to each other so perfectly. It's a fascinating world, so let's dive right in.
I mean, have you ever really thought about it? You click a button right here on your laptop, and in a blink, a video starts playing from a server that could be on the other side of the planet. It honestly feels like pure magic, doesn't it? Well, behind that magic is a surprisingly logical and, I must say, very elegant system.
So here's our roadmap for this explainer. First, we'll look at the fundamental challenge of getting separate computers to even understand each other. Then, we'll explore the rules that make it all work. After that, we'll see a clever trick called RPC that makes life so much easier for programmers, and we'll finish with the key takeaways.
Okay, so what's the core problem here? Well, imagine a team of people who can't see or hear each other and don't share a single thought. That's kind of like a distributed system. Each computer is its own island with its own memory, its own brain. So for them to work together, they have to communicate. But how do you do that without a shared brain? That right there is the big challenge.
The answer? You create a common language, a shared rule book. In the world of networking, we call these rules protocols. To avoid just complete and utter chaos, any two computers that want to talk must agree on exactly what the bits and bytes they're sending back and forth actually mean. It's all about building a system of trust, layer by layer. Now, to really get our heads around this, let's use an analogy. Let's imagine this whole process is like a global postal service. The data you want to send, say your request to play that video, is like a letter you've just finished writing. The question is, how does that letter get from your desk all the way to a server in, say, another country? Well, that letter doesn't just magically appear there, right? It goes through a whole system, layer by layer. Each layer of the postal service has a very specific job to do, adding stamps, addresses, sorting, to make sure your letter gets to the right place safely. Let's see how that works. Okay, let's follow our letter's journey. It all starts at the top, in the application layer. That's your web browser writing the letter, basically creating the request for the video. Next, the transport layer puts it in an envelope, making sure it's addressed to the right application, like the video player. Then the network layer slaps the full street address on it, the server's IP address. After that, the data link layer is like the local post office, doing a final check for any errors. And finally, the physical layer, that's the mail truck, the actual wires and cables that carry the message across the world as bits of data. See? Each layer has its part to play. Now, all of these layers are absolutely essential. But can you imagine if you, as a programmer, had to worry about all of that for every single request? It would be a nightmare. As the quote says, the programmer just wants to read some data. They don't want to know about all the fishy stuff happening behind the scenes. They don't want to be a postal worker. So that leads to a brilliant question. What if we could make all that complexity just disappear?
Well, that dream is a reality, and it is the foundation of so much of modern software. It's made possible by this incredibly elegant idea called a remote procedure call, or RPC. And the goal is beautifully simple. Make calling a function on another computer, far away, feel exactly the same as calling one right here on your own machine.
And just look at this. It says it all. On the left, a totally normal local function call. On the right, a call to a function on a remote server. To the programmer, they look exactly the same. You literally cannot tell the difference. All that complexity of the network is completely hidden. It's a beautiful thing called transparency. So, what RPC really does is act as a shield. It's a programming model that hides all those messy networking layers we just talked about. The programmer just writes a simple line of code to call a function. They don't have to think about packing data into messages, sending them, or getting a response. The RPC system handles all of that dirty work behind the scenes. I really like this analogy. Think of RPC like a magic phone in a big office. You don't need to know anything about the telephone wires or the switchboard operators. You just dial your colleague's extension and ask them for a file. In the world of RPC, you have these two little magic assistants. We call them stubs that handle all the complicated logistics for you. So let's see how these magic assistants actually pull it off. First, your program calls what it thinks is a normal local function. But really, it's calling the first magic assistant, the client stub. The stub then takes all your instructions and packs them into a neat little package for the network. We call that marshalling. That package is sent across the network, where the server stub, the second magic assistant, receives it, unpacks it, and makes the real call on the server.
The result then comes all the way back following the same steps in reverse. It's a very clever dance, and it's all completely invisible to the programmer. All right, so let's tie this all together now. We've really looked at two huge ideas today that are like two sides of the very same coin: the complex foundation of how networks work and the beautiful, simple abstraction we can build on top of it. This table sums it up perfectly. You've got layered protocols, that's our foundation. That's the complex, but absolutely necessary, postal service that makes sure our messages get from point A to point B reliably. It makes it all possible. And then, on top of that foundation, we build the abstraction RPC. That's our magic phone call that hides all the messy details, letting programmers focus on building great applications, not on being network engineers. The foundation enables the abstraction.
And that leaves us with one final important thought. This RPC abstraction is wonderful. It's simple, but, in the real world, networks can be slow. Connections can drop. Things can and do go wrong. So the question I want to leave you with is this: when does this beautiful, simple magic trick break down? When is a developer forced to look past the magic, peel back the layers, and deal with the messy reality of the network underneath? Thanks for watching, and see you in the next session of this series.